All right, I guess we'll get started. A few more people probably trickling in. I hope you guys had a good lunch. I stuffed myself full of a burrito, so I'm very happy. But I hope you don't fall asleep during this. This is Building Scalable Distributed Job Queues with Redis and Redis Client. I am Mike Friedman, also known as Frito. A quick note before we begin this. Back, I don't know, about 6 months or so, I think in January or something, when I wrote the abstract for this talk, the original plan was to talk about work that I was doing for my employer at the time and how we were using Redis for job queues and what we were doing it. As it happens, I'm no longer employed by that employer. I won't go into why. But I've had to shift the topic here a little bit, and so rather than going into all that interesting data, we're going to focus on a similar thing that I was doing for a project of my own, which is kind of an ongoing hobby, which I expect to release sometime this summer. So the information that we're going to see is not quite as detailed as I would have liked because I no longer have access to these very big, interesting data sets, but hopefully you will find some of this useful. So what is Redis? Redis is an open source key value store. What is especially appealing about it is that it is simple and fast. And it's simple because it does a small number of things very well. It's not structured. It's not a structured document store where you can query documents and look inside of things. But it does support certain structured types, which we'll look at a little bit later. And it's very fast. Redis actually stores all the data in a given data set in memory. And if that sounds insane to you, well, if you're dealing with, billions of gigabytes of data, then you wouldn't want to use this tool. It would be the wrong tool for the job. But if you're dealing with a lot of ephemeral data, stuff that you have to grab from one place, munge around a little bit, and then put it somewhere else, Redis can be very useful. So again, it stores everything in memory or virtual memory, as the case may be. It does flush to disk occasionally to allow you to restore data in between server reboots, but you can lose data. It's not going to guarantee that your data is going to be stored. There's no consistency or anything like that that you'd find with a relational database or a document store like MongoDB or something like that. Redis is not a relational database. It is not a document store. It is not structured. You cannot query the data within Redis, although it does have, I mentioned before, structured types, which we'll look at a little bit. And unlike a lot of modern tools like MongoDB and CouchDB and so forth and Cassandra, Redis does not work over HTTP. It has its own protocol with a lot less overhead, and we'll look a little bit at the protocol too. So we'll talk a little bit about the data types that you can store in Redis. The simplest is a string. This is equivalent to a Perl scalar. It can hold a string of text, a number. It can hold a blob of JSON text, which is something that I use a lot. Anything that you could stick in a Perl scalar, you could stick in a Redis string. Not including references, though. Redis can't really refer to other items in Redis except by name. Lists are analogous to Perl arrays. You can have 0 or more items in a list. They have an order. Redis has commands called rpush, rpop, lpush, and lpop. The R's and the L's stand for right and left if you're reading the list from left to right. If your native language is Hebrew or Arabic, you might find that confusing, but these are analogous to push, pop, unshift, and shift in Perl. Redis also supports hashes as of, I think, version 2.0 or maybe 2.2. Just like Perl hashes, these store key value pairs. They are unordered. And again, Redis has commands hdel, hexists, hkeys, and hvals, which are analogous to the equivalent Perl operators. There are also some more interesting types which don't have direct analogs in Perl, but which we can sort of shoehorn into structures. One example of these is sets. A set is essentially what it is in mathematics. It's a group of objects in no particular order. You can think of a set as a Perl hash where all the values are undefined. And you've probably used structures like this where you just want to use the features of Perl hashes without caring about the values. So you just set everything to undef or everything to 1. And that's essentially what a Redis set is. Again, there are Redis commands, which are roughly analogous to Perl hashes. srem removes a hash. Sismember checks if something is in the set. Smembers will give you all of them. Sets can do a lot of operations. These are built into Redis. So you can take the union of a set. You can take the intersection, which are the items between two sets that are in common. You can add and remove elements. You can get cardinality, which is just a fancy way of saying how many things are in the set. And all of these set operations can be implemented with Perl hashes. I think it's an interesting idea to think of how to do that, so I won't go into that, but I'll leave that as an exercise for you if you want to play around with Perl hashes and figure out how you would do a union or an intersection. It's a worthy exercise. There are also these things called sorted sets, or Z-sets. Like sets, these also have 0 or more keys. Each one has a score, which must be a number. The score of each item simply determines the order that these items are retrieved in. So you can have 10 items. Each one has a score from between 1 and 10, and that's the order you'll get them in. You can change scores and so forth. And this is probably the most foreign type of structure for people who are used to Perl. But we can sort of model this as a hash where the keys are the members. The keys are the members of the set, and the values are the scores. And again, here are some examples of some more Redis commands. These all start with Z. These are sort of analogous to these Perl hash operators. We'll look a little bit more into these in a minute. And again, set operations. These are just a few examples of Redis commands. Redis has a lot more commands, over 100, for working with lists and hashes and sets and everything. You can find them at the redis.io site, which is everything you want to know about Redis. So let's look a little bit about the Redis protocol. I mentioned earlier it's not HTTP. You don't open a connection, make a request, get a document back, and close the connection. You have a stateful persistent connection over TCP. It is an interactive protocol, so you type commands, you get answers back. It's very easy to debug this just by telnetting to the Redis server and typing commands. Actually, there are two protocols. There's an old protocol which was developed for the first versions of Redis, which is very simple and straightforward and made sense for what Redis did at the time, which was basically to store strings and lists and didn't really do anything else. You simply send commands one per line, you terminate with a CRLF, and you get a response back from the server. Here's an example of what an old protocol might look like. This sets the value of a string. The server response is in orange. It responds with plus OK. The plus means it was successful. There are problems with the old protocol. You separate the command and data with white space. As we just saw, we separated the key name and the value with white space. This becomes a problem when you need to escape stuff. You want values with white space in them. It becomes a problem when you're dealing with binary data or encoded strings. You want to deal with UTF-8 data or other languages and encodings. And it's kind of inconsistent. It made sense in the very early versions of Redis, but as more advanced structures were added, the syntax didn't exactly sort of fit with that and wasn't really designed for expansion. The new protocol, is called the Unified Request Protocol, or the ERP, as I like to say. And this protocol offers a lot of advantages. It gives you a consistent command syntax. Unlike the prior protocol where you had to parse white space and deal with spaces between items, everything is prefixed with a byte length. And note that that's a byte length, not a character length. That becomes very important later. So there's no escaping or decoding or encoding required. You simply send the length in bytes, and everything is round-trip safe. So here's an example of how to use the ERP, and we'll go over this line by line. The first line is *3. The star indicates that this is what's called a multi-bulk message. The 3 indicates that this message has 3 parts. And you'll see so there's the *3. The first part is this part, which begins with a $sign. In the URP, all messages that begin with a $sign are a bulk message. So a multi-bulk message is made up of several bulk messages. And this is a very simple syntax. All it says is this thing is 3 bytes, which it is, and we see set, followed by an 8-byte thing, which is my string, followed by a 6-byte string, which is foobar. So all this is saying is set my string foobar, and we see the response from the server is OK. So let's take, back when I was first learning about Redis and looking into using this for the projects that we were working on, of course the first thing I did was go to CPAN and see what was there. And so what I discovered is there are a couple things on CPAN from working with Redis. They were not adequate for what I wanted to do at the time, and some of this may have changed since then. This information is based on the research I did at the time. So let's first look at Redis.pm, which has been on CPAN for quite a while. It works. It has a simple interface. It does some very odd things with encoding, which we'll look at in a little more detail later. And it does not support the newer data types which have since been added to Redis, such as Redis hashes. It does emulate this by cheating a little bit. For example, if you want to, Redis.pm has a hash module which will emulate hashes by simply assigning Redis strings with prefixed names and adding a little layer on top of that, but those aren't real Redis hashes, and you can't use the Redis operators on them. And it uses autoload for a bunch of stuff, and I hate autoload. Autoload has a lot of problems. It's slow. It leads to weird things. And, you know, it's useful in places, but it always bugs me when I see it. So I want to avoid it when I can. So I mentioned some encoding issues. By default, Redis.pm will take all the information coming from your Redis server and forcibly turn the UTF-8 flag on. This is insanely wrong. It's horribly broken. Right now, that's the default. You can turn this behavior off. I looked actually just last evening, and the documentation now says, it might have said this before, but I've forgotten. It now says that in a future version, this will be turned off by default, which is a good thing. But right now, if you're dealing with binary data or character data in other encodings, you have to make sure to turn that off if you're going to use Redis.pm. There's also the Hi Redis module on CPAN. Hi Redis is a binary client for Redis. This is simply a wrapper around it. If you have Hi Redis available, it works fine. The disadvantage is it's an external binary dependency, and dealing with the IPC between your program and Hi Redis is kind of slow, especially if you are making a lot of queries. But I could not find a Perl module that had native support for Redis hashes and sets and z-sets that did not have binary dependencies and did not have full support for the ERP. That last item might be outdated. I think Redis.pm now does have better support for URP. That is, until now. So Redis client is on CPAN. It's there. You can find it. There's the Meta CPAN page. That guy looks just like me. The source is all on GitHub. It's under the GitHub name Perl-Redis-client. There it is. It's already gotten a few contributions and patches on GitHub, which I'm immensely thankful for. So let's take a look at what Redis client does and how the distribution is set up. The main module is Redis/client.pm. This is the primary interface that you'll talk to get your Redis connection set up, and it also implements all of the 100 and some odd Redis commands. Probably the most important module is the role/URP module. This is a Moose role, which implements the Unified Request Protocol. So what that means is it transforms your messages into multi-bulk ERP messages. It parses multi-bulk messages back from the server and passes that information up to the client code. It's abstract enough that you can easily use it outside of the Redis client distribution. So if for some reason you had some code somewhere that needed to implement the ERP protocol, you can just use this role to do it. There's also this tied role, and this is implements classes which map Redis types directly to Perl. We talked a little bit about how Redis lists are analogous to Perl arrays and so forth, and we'll look at a couple examples of how those work. And finally, there are a bunch of these modules which implement various classes for dealing with the various Redis data types, and here they are. Those are all 5 of them. Actually, let me mention this. Also, Redis has a publish and subscribe module. This allows you to set up connections that will automatically receive messages as they're pushed onto Redis pub/sub items. I haven't used it before, and Redis client currently does not really support it, but I'm hoping to add that in the future. So we mentioned encoding a little bit before. And Redis client is going to make no assumptions about your data encoding by default. So if you need to pass data that is already encoded, that means in UTF-8 or some other binary form. Otherwise, if you try to send character data over a socket, you will get wide character warnings and your data will be broken by the time it gets to Redis. Similarly, data that you get from Redis is not decoded. You need to decode it yourself, which is the correct way to do that. In addition, there will be a callback system for dealing with encoding and decoding and inflating and deflating data, such as if you're storing JSON. That doesn't exist yet, but I have it in a branch somewhere, almost ready to go. So let's look at some actual code examples. Here we're just going to construct our Redis object. We're using the defaults. The constructor does take arguments to specify your server and port number and so forth. This just uses localhost and the default port number, which is like 6739 or something like that. And here we'll just use the Redis set command. We saw before what that actually looks like on the socket using a multi-bulk syntax. And here we'll just set a string called myString to foo. We can get it back. Here's an example of working with lists. We can push 3 values onto the end of a list called myList. We can use rpop, that's right side pop, which is equivalent to Perl pop, to get the last item off that list, which would be the string 3. Hashes, again, work similarly. We specify the name of the hash, the key, and the value to set one. And to get values from the hash, we specify the name of the hash and the key, and you see that would return 42. So here's something more interesting, which is these tied classes I mentioned before. So what we're going to do is we're going to take a single hash in a Redis store and tie it to a Perl hash. And so we do that by using the Redis client hash class name to tie. The key argument you see here is the name of the hash in the Redis store, and the client argument is that Redis object which contains our connection that we just saw before. And that contains the server host name and the port and so forth. Once we do this, we can use all the Perl operators we're familiar with. We can get the keys. We can check if a key exists. We can delete a key. We can iterate over keys using each. Anything that you can do with a Perl hash, you can do with a Redis hash now using these tied modules. And there are tied modules for lists and so forth as well. So now we get to the meat of this, which is what we're doing with job queues. And the goal here, and this was the goal both for the task at my former employer and the secret hobby project I mentioned before, which I'm working on now, is we want to add jobs to the queue, fetch them as soon as possible, and execute them as soon as possible, prevent duplicates. So we want to have some kind of form of, maybe not necessarily transactions, but some form of flagging that we can use to prevent duplicates. And we want it robust enough so that we can execute thousands of jobs every hour. The old model, and I'm sure you've probably implemented one of these. I've implemented this probably a dozen times. It's one of those things where you always know it's kind of wrong when you do it, but the tool is there, and you just sort of do it anyway, and it works 80%, and it's usually kind of good enough. And that is, you have a relational database, so you just set up a job tables, you add records for your jobs, you have a daemon that maybe checks the table every second or so to look for a job. You set a status that says running or something, so 2 daemons don't grab it at the same time. And then when it's finished, either it worked or it didn't work, something went wrong, and you store that back in the database. And, this is sort of kind of a universal anti-pattern that everybody has done and wrestled with, I think, over the course of their programming career. So it has problems. Relational databases are slow. They're not, as much as we try to optimize database stuff, databases are not designed to be fast. They're designed to be relational. They're designed to enforce transactional security. They're designed to enforce the relational data model, which are all good things, but which are really kind of not the things we want for this type of system. So here's how we will implement a queue using Redis. We'll use a single list. That'll be our queue. We have already seen that we can pop items off, or rather shift items off the beginning of a list and push them onto the end. We can use JSON to store all the arguments and metadata we need to run the job in Redis. And you don't have to use JSON. You can use whatever you want. I really like JSON, though. So we mentioned lpop before, which pops an item off the left or shifts it in Perl terms. There's also another Redis command called blpop, which does a blocking pop. And the reason this is useful is if you do an lpop and there's nothing on that list, you just get undef back, or you just get a null item in Redis terms. So a blocking pop is just like reading data from a console. The program will wait for data to be there before continuing on. So here's some example code. We'll use these four modules: Redis client, JSON XS for parsing the JSON, module load. This is what I use to load my job class modules, because this project actually has hundreds of different job classes and don't want to load them all up front. And try catch for dealing with exceptions. So again, we'll instantiate the Redis object as usual. Here's an example of how we might add a job to the queue. All we do is we create a simple Perl hashref here. We include the class name of the job class, the method that we want to call on that class, and we'll have two hashes containing arguments for the constructor and arguments for the methods. None of this is strictly necessary. This is just the way my system is designed. And then we'll use our Redis object to push that on. And we use encode JSON from JSON XS to turn that structure into a JSON string. And here's an example of a simple dispatcher loop. So we mentioned blpop before, so we'll just wait for something to appear on the jobs queue. We get that string, we decode it. We pull out the constructor and method arguments into cargs and margs. The class, we add that myapp prefix, which is just something I have in my project, so I don't have to type the common parts of all the job class names every time. And the method that we want to call is in the method field right there from our job. So we get all that. We load the class using module load. We instantiate the class using the constructor arguments. And then we'll try to run that method using the method arguments. If there's an error, we store it. In this case, I'm storing historical error about the jobs in a relational database because I want to save all that data and run queries on it later. You certainly don't have to do this. That's just the what I'm using for this project. And again, if it works and there's no exception, we store that data as well. So let's look at some benchmarks of doing this versus doing a relational database. And I want to say up front, these are terrible benchmarks. These are highly dependent on the system I was building at the time. I didn't try very hard to optimize it in either case, especially when dealing with relational databases, in this case MySQL. There are all sorts of server options and index options and things you can do to try to get the most speed out of it. I did not do those things. I just sort of tried one after the other and saw which worked best. So it's important that when you're looking at this stuff, you do your own evaluation and you figure out what the appropriate model is for you. So here's the old system I mentioned with a MySQL jobs table. I populated this with 5 million test jobs, and I tested it under 3 circumstances, with 1 worker pulling in database, 10 workers, and 100 workers. Most of the time spent running these jobs is within the job class itself, so the actual dispatcher that's used is somewhat irrelevant. These jobs go out on the network and do stuff with various web services. But what's interesting is the scaling here. With 10 workers, we get a little less than 10 times the jobs per minute. With 100 workers, it's disastrous. We get less than half of what we would expect with 3,892 jobs per minute. But with 10 times as many workers, we would want 7,000 jobs per minute. We're not getting anywhere near that. The bottleneck here is the fact that this is really highly bidirectional, which is something that relational databases are not good at. We're constantly polling the database, looking for records, and at the same time, when each job finishes, we're writing that success or error data back to the database. Relational databases can perform really well if you have 99% reads and 1% writes, but here it's about evenly distributed, half reading and half writing. And that kills the relational performance once you get up to 100 processes querying the database. So with the Redis queue, we see that it actually scales a lot better. With 10 workers, we actually get more than 10 times the number of jobs per minute. That doesn't mean anything because, like I said, most of the time in this benchmark is within the job classes itself, so you can't really draw any conclusions from that. But look at 100 workers, we get 9,222 jobs per minute, which is a fantastic improvement over the relational model. So to repeat myself, these benchmarks are stupid. Do your own. And it works for me, so I'm happy with it. So thank you very much. If you have any questions, I will be happy to take them now. Yes?
Does Redis have any type of multiple blocking, like a multiple list at the same time?
Yes, you can. Each client can execute a blocking pop on a single list.
Select on multiple lists at the same time.
I'm not sure. I think there might be a command that does that. If there is, I haven't researched it, though, but it kind of rings a bell in my head. I think there might be a way to block on multiple queues simultaneously. In this project, this is a very simplified example of the actual dispatcher that I use in this project. In that, I actually have multiple queues, about 100 of them, for different types of jobs, and I just cycle over them and fork off processes to listen for each queue. Yes?
With Redis, what's the sort of crash recovery like?
So, if Redis crashes, Redis does, from time to time, flush all of its data to disk. All of the data that Redis is actively using is stored in memory. If Redis crashes or if the machine goes down or something, you will lose whatever was written to the store after the last flush. So you cannot use Redis as a canonical data store because you will lose data in a crash situation. So Redis, I think I mentioned in the beginning, great for ephemeral data, great for kind of job data, temporary data that you need to store while you're working on it. But your actual canonical data needs to come from a real database system or files on disk or something like that. Yeah.
One quick follow-up I'd add to that is that using a database, you can actually dial back the sort of guarantees it gives, and you will get better performance.
Yeah.
What Redis going to do. Just so you know that not just because you're using a database means it's slow. You can actually turn it back.
Yep, absolutely true. Yes.
So recent Redis does actually have the form of like write-ahead logging. They call it the append which actually gives you better data consistency guarantee as far as stuff getting lost at a little bit of a performance cost. So you can dial that in the opposite direction as well. It's a new feature, so I guess I wouldn't call it proven yet, though.
Thank you. Yeah.
So if you're just pulling things off the queue when you want a new job, if the worker dies while it's processing, is that job lost?
Yeah, that job will be lost in this example because I'm using a POP. And when you use a POP, you get the data back from the server, and then it's gone from that list. So if you wanted to build a more robust system that had some kind of crash recovery, you might want to store in-progress jobs in some temporary place that you can recover from. In this example, there is no recovery. If the job queue goes down while the job is in progress, the job is lost. For my particular project, that's okay. It doesn't matter if you lose the occasional job. But if it's not okay, you need to design something extra to deal with that. Yeah.
So you move from MySQL to Redis to improve concurrency and have less contention for pulling jobs out of the database?
Yeah.
When you say that you store all the results in the database,
Yes.
wouldn't you still have contention there? Would it make more sense to use like a log file?
You could. The primary, in my case, it doesn't matter so much if writing the results to the database is a little bit slow. The main problem that looked like when you were writing to the database and trying to pull it at the same time was you would have to lock these tables to write the results to the database, which would block the polling. And again, you can turn off those protections. You don't have to index stuff, and you don't have to necessarily lock the tables to deal with that. But that can lead to other problems, and I found this just to be much simpler. So in this case, it's only writing to the database. The live queue doesn't read anything from the database. I do run reports against the database, and that seems to work better for my purposes. Yeah.
If you're using MySQL as a data store, I highly recommend you check out Q4M, which is a custom storage engine for MySQL, which does just queuing. I mean, it's a message queue, right? And it's super fast. I'd like to see a comparison between your approach.
Yeah, that would be interesting. I have heard of Q4M, and unfortunately I haven't had time to look into it, but I'd like to do that at some point. Any other questions? Yeah.
Is it typical Redis setup that you have the Redis server running on the same machine as the worker or the application?
Right now I do, because this project is still in development. Redis works over TCP, so you can have the Redis server on another machine, and you can have your workers on other machines if you want to. Right now, for the tests that you saw in the benchmark, I had the Redis server running on one machine. I had half the workers running on the same machine and half on another machine. In a real-life situation, you'd probably have a wider distribution of machines.
Can you have multiple servers?
You can't have multiple servers.
Like they're synchronizing their data?
Yeah, there's no real replication as far as I'm aware. That's something that's been discussed for future versions of Redis. You could build your own replication if you want to, but again, because it's not a canonical data store, there's the argument to be made that there's really no point for replication. If you have so much data that Redis is too slow, or you end up thrashing it because it's writing everything to virtual memory, and you still want to use Redis for that, then the way to do it would be to set up multiple Redis servers with different chunks or shards of your data. But if your data grows to that point, you should probably be looking into something else.
It's just that if you lose that hardware, then the data is gone.
Yeah, and that's it. That's why you don't use it to store your canonical data. Yep.
It does have master-slave replication.
Oh, it does? Okay. My information's out of date then. So there is some master-slave replication for Redis. Thank you. Any other questions? All right. Well, thank you very much. Thanks.